All right, I'm going to cover 6.2 and 6.4 today. The reason I'm going all over the place is because I'm trying to teach it in the first part. I taught 6.1 and 6.5 was basic algebra. The second and 2 and 4 is another application of algebra, which is called formulas. And then word problems is 6.3. So I don't think I need to cover word problems till after I covered what you work the word problems with. So that's why I decided to kind of break it up. So today we're going over 6.2 and 6.4. Like I said, you've already done the hard work for the unit. The hard work was in 6.1 and 6.5 because that was the actual learning or revisiting from a long time ago stuff that you haven't seen, which is algebra. Okay? Now, formula, what's the difference in a formula and an equation? Well, an equation is kind of like saying a car. Okay? Everybody in here could say that that parking lot is full of cars. Okay, there'll only be one geek in the group and say, well, there's a van out there and there's a truck. Shut up. All right? There are cars out there. All right? If you want to get technical, they are vehicles. All right? But most people say cars. It's kind of like when you say Coke. When you say Coke, are you saying Coca-Cola or are you saying all Cokes? You saying all Cokes. Most people say Coke. All right? It's like Xerox machine. You ever heard somebody say, I'm going to go down to Xerox? This, it's not Xerox. Xerox is a brand. But we use those. Are y'all listening? Is everybody listening or are y'all talking amongst yourselves? Y'all good? All right. Equation is a big umbrella. Okay? It's got a lot of stuff under it. Okay? A lot of stuff. So, when you're talking about an equation, you could be talking about the algebraic equation, which is 2x plus 4 is equal to 6. It could be 1/2 times x plus 3 is equal to 12. Or it could be a formula. Or it could be a direct proportion, which we're going to get into an inverse. It could be that. So when I say equation, as long as you can work an equation, then you can pretty much handle these. And in 6.1 and 6.5, you learned how to handle not only an equation, but you learned how to work an inequality also. Okay? So now we're going to go over formulas. Now, what is a formula? Well, this is a two-step equation. That's more like a truck. Okay? This is a three-step equation. That's more like an SUV. This is more like a van. Okay? Now I'm getting into, instead of just saying vehicles, I'm getting in and I'm actually giving you a little bit more detail. I'm saying, okay, we're going to narrow it down a little bit more. And we're going to take it down to a formula, where this is a motorcycle. Or not a motorcycle, but let's see, what is a truck, SUV, van, we'll call it a four-door sedan. Four-door sedan. All right? It's not a two-door, it's a four-door sedan. So there's different forms of cars. When you just say cars or vehicles, there's different forms. So I'm taking it down. So we're going to be working with these two types of equations. Now, when you're dealing with a formula, there's two ways to deal with a formula. There is the solve for a variable, which is usually the easiest. Plug and chug, I'm sorry. There's two forms of formulas. There's plug and chug, and then there is solve. Now again, I told you that the first two is the most difficult, and then this is the less difficult. So most of you probably won't have a problem with these two sections. You will have a problem with the second section before you will with the first section. Okay, this first section is going to be pretty easy. Second section may, bog you down a little bit. Plug and chug. X is equal to 4, Y is equal to 6. X plus Y. You plug and chug. 4 plus 6. Now this is an algebraic equation or algebraic expression. I can change that and say perimeter is equal to 2L plus 2W. L is equal to 6. W is equal to 5. This is a formula. This is an equation. Okay? This is just an algebraic equation. This is a formula. A formula is more detailed, and it usually has a what? A purpose. Okay? This is perimeter. Perimeter of a quadrilateral, meaning a square or a rectangle. And you take the length. If the length is 6 feet and the width is 5 feet, then you can actually figure the perimeter by adding up all the sides, or you can do 2L plus 2W, and you plug and chug. 2 times 6 plus 2 times 5. 12 plus 10 is 22. So it's 22 feet around this area. Now again, I know some of y'all invented formulas, just like some of y'all wrote the math book that you're using. Okay, I realize that y'all think y'all know everything, but some people might not. Okay? So that's a plug and chug equation. On the test, you might get one of these. So I'm not gonna insult your intelligence by making you do a lot of these. This equal to 10, and 10 is equal to 10. So remember, determine. Remember I told you determine means what? Plug and what? Chug. So that's what we did in 6.1. Both of them are formulas, but this one is more of a formula because it's more detailed. It actually tells you something in real life, where X and Y is just kind of an open variable. Okay, so you should be able to plug and chug those. Remember your order of operations. If you're given P is equal to 1/2 X plus W, and X is equal to 2, and W is equal to 5 or 6, then you're going to do what's in the parentheses, what? First, then multiply by the 1/2. So order of operations, you got to remember your order of operations, and we did that in 6.1 when we were doing the, determining and evaluation, when you plugged and chugged into the algebraic expression. Okay? Fish? All right, so what about the solve? Well, the solve is when they tell you to solve for a variable before you plug and chug. Solve for a variable. Now, the reason we cover this in math, not just for the math, but for the what? Sciences. Okay, we have to touch on it because some of you will go into biology, some of you will take biology, some of you will take chemistry. I don't know. Nobody knows what your future holds. And you'll be introduced to formulas. Well, sometimes the formulas do not give you exactly what you want. So you have to what? You have to solve for the variable that you want. Okay? One of the most used is this one. And I showed you this one with scientific notation. Distance equals rate times what? Time. And I give you the distance and I give you the time. Well, that doesn't help me because that's solved for D. So if I give you the distance equals 4 miles and the time is equal to 6 minutes or whatever, then that's not going to help me because this is solved for D. So if I got D, if I got this one, and I've got this one, then I need to solve it for what? R. And I need to divide by T on both sides. So that would be divide by T on both sides. So you can get R what? By itself. And now R is equal to D over T. And now I can plug it in, whatever I wrote down over here, plug it in and get the answer. Okay? Now, Sometimes this can be real easy algebra. Sometimes you have to do order of operations in reverse. And what I mean by that, please excuse my dear Aunt Sally. Algebra, math is this way. Algebra is what? The opposite. So if you're given subtraction, you need to undo it first. If you're given addition, you need to go down that. Remember this, because when you're working with solving for a variable and you're given a bunch of steps, you need to know which one to take care of first. Capiche? So we'll do a couple of examples of this, and the second session is the one that'll probably hinder you a little bit. This one I don't think is going to hinder you. And that is direct and inverse variation. All right. So if I give you the following, pi r squared, I think it's pi r squared. Is it area? Oh well, I'm just going to make it up. Area equal to pi r squared, and r is equal to 4. Okay, that's a formula, and it's the area of a circle. I think it's the area. I think it is, because the cylinder is volume. Cylinder would be times the height. So I think that's right. Maybe wrong. Anyway, area is equal to pi r squared. So the first thing to do is you rewrite it, and whatever the variable is, you put a set of parentheses around it, and you stick in that 4. And 4 squared is what? 16, Hubert. 16 times 3 is what? 48. And some change. Of course, you would type in your calculator, you would type in 3.14 or pi and get whatever it comes out to be. Okay? That's why I put the squiggle with the dot. That means like estimate. Okay, so you need to write calculator, you need to calculate that with pi. Okay? So again, I don't want to spend a lot of time on that because I think y'all can do that, because you did it in 6.1. All right, the other type problem. No, this is a resistance problem. I don't know if it's, I'm just going to say E is equal to R sub 1 plus R sub 2 plus R sub 3 over 4. And I want you to solve for R sub 2. Now, remember back in 6.1 and 6.5, when you're given a fraction, what's the first thing you do to it? Just like stinking trash. What do you do to it? You get rid of it. By multiplying through by what? Common denominator. What's the denominator? 4. So I'm going to multiply by 4 on both sides. And what's that going to give me? 4e is equal to R sub 1. Oops. R sub 1 plus R sub 2 plus R sub 3. And how do you get rid of adding R sub 1 and R sub 3? Subtract R sub 1 and R sub 3, or take it across the what? Take it across the river, and it becomes what? 4e minus R sub 1 minus R sub 3 is equal to R sub what? If you did 6.1 and 6.5 and you did the homework, then this should not be a problem. Now, what's the biggest problem? The biggest problem is that students see what instead of numbers? They see letters, and they start to what? Freak out. The laws still apply that you learned in 6.1 and 6.3. If you need to distribute, distribute. If you need to get rid of a fraction, get rid of the fraction. If you need to multiply through by a decimal, multiply through by a decimal. All those rules still apply. So if you've learned them in 6.1 and 6.5, then you should just continue doing what you're doing in those sections. Okay? But I'll expect a couple of questions when we go over homework, before the test and everything. When we go over that, I'll probably get a couple, and that's not a big deal. I usually get 2 or 3 of these before the test. Okay? Now, I think that's 6.2. Work on that. I don't think you'll have much problem with it. 6.4, however, does sometimes give a little bit of a problem. All right? Somebody got a book? Nobody got a book? Anybody got a book? You got one? Let me see if I could save me from having to go up there. What did I say it was? 6 point what? 4. Yeah, there it is. Turn to page, I just want to see what page it was on. There it is. Bottom of page 312. Bottom of page 312. You need to learn that box. Bottom of 312. Now, do they use D? D is equal to R times T, D is equal to R over T, or do they use D is equal to R over X? What do they use? What variables do they use? Y over X? Or YX?
Y equals KX.
Okay, Y is equal to KX. Y is equal to K. Different books use different letters. KX. Y is equal to K over X.
Yeah.
And Y is equal to KXZ, or does it use different ones?
You got KXZ.
Okay. XZ. All right. This is called direct. This is called inverse. Make sure they call it inverse. Do they call it inverse or inverse?
Inverse.
Okay. And this is joint. These are called the 3 variations. Now, do y'all remember when I told y'all, I might not have told y'all about baking the cookies? If you bake, if the ingredients called for 1 dozen cookies, if you want 3 dozen, what do? You multiply by 3, right? You want 5 dozen, you multiply by 5, right? Okay. That's called a multiplier. Write that down. What you multiply by, and to make those cookies is called the multiplier. Well, that's what K is. But in formulas, K sometimes is multiplied. K is sometimes what? Divided, and sometimes it's multiplied twice. Okay? When K is used in a formula, I like to tell students it's called a fudge factor. Okay, now some of you may not know what a fudge factor is, and they may not even use that term anymore in science. Okay? But in science, I can remember when I was in physics at Clemson, they told us this is a fudge factor, this is a fudge factor, this is a fudge factor. A fudge factor is a number that makes the formula what? Okay, what'd you say?
True.
True. Yeah. Or make it work. Either one of those words will work. It's like I told you, if I make 1 dozen cookies with a cup of milk, then how many cups of milk do I need to make 3 dozen? I multiply it by 3. I use that multiplier and I multiply it. So that's what K is. K is called a what? Anybody know the word for it? Starts with a C. A constant. Write that down. K is a constant. Usually, whether you're in science or math, K is usually the constant or the multiplier, and it does not change. That's the only variable that does not change in the formula. Write that down and highlight it. K does not change. Because what happens is, you memorize these 3. Okay, you memorize these 3. This is the way it goes. You memorize those 3. You read the word problem, and then you substitute in the variables. Now when you substitute those variables in, everything's going to change except for what? K stays K. It does not change. It's actually a lowercase k. All right? It does not change. So you can change y into q, and you can change x into w, but you can't change k because k stands for constant. It stays the same. It is the multiplier. It is the fudge factor that makes the formula work. So your first step tonight when you go home is to memorize those three formulas and the name of them, because the question is going to tell you which one to use. Now, sometimes they're going to tell you to mix two of them together. And that's where you're going to have to rely on your what? Your brain. You're going to have to rely on it. Kind of like a crutch. You're going to have to rely on it to keep you up. Or you could just what? Quit or fail. Yes, you just quit. Yeah, just throw your pencil down and make it pop up against the notebook paper. Okay? That's what people usually do. So, let me show you an example. I'll pull up an example. The best way to show these are with examples. I don't even want to go through the theory and the derivation because it ain't going to do you no good. It's not going to do me any good. It's just going to be extra work for both of us. So I'm going to throw up an example. This is 6.4. Now there's three type questions with these problems. Three types. And I'll give you those in just a minute. My mouse turned on. I'll just go to 6.4. I did say 6.4, didn't I? Yeah. And study plan. Now, what are the three types of problems? There's 3 or 4 type problems. I can't remember all the different problems they make in each book. And this is a new book, I think. It brings more new ones in. One type problem is plug and chug. Okay, they give you the numbers for everything, and they say k is equal to 4 and y is equal to 6. And they want you to find x. So that's pretty self-explanatory. That's the easiest. The second type problem, plug and chug and find k. Okay? Plug and chug and find k. The third type problem, plug and chug, find k, and then they're going to give you more info. I think there's 3 type problems, okay? So those are the 3 type problems you're going to see in this homework. And I'll just click on one and see which one they're going to give us. I don't pick the first one because the first one is usually pretty easy. Yeah, they've done, yeah, these are easy. Is this direct or in? I'm not going to, I'll let y'all go through those. I'm not going to go through those. Come on, get to the problems. Okay, there we go. Here is a easy type problem. Write the variation and find the quantity indicated. This is plug and chug. First thing you do, find out which one it is. Which one is it? I heard, That's what I heard. Up here, that's what I heard. I didn't even hear a syllable. All I heard was, I'm waiting till somebody enunciates that word. Which one of those 3 formulas are we going to use? Thank you. Y is equal to k times what? X. All right. Now we're going to read the sentence from left to right. What variable comes first? So y is replaced by r. What is k replaced by? It stays the same. It never is replaced. And what's the last variable? So x is going to become s. Now the reason you do that is because different formulas have different variables in it. You're not going to say s is equal to tangerines, why would you say S is equal to tangerines? Tangerines start with a T. Okay? That's why. Because you're going to have different variables for different formulas. And you got to learn to stick them in wherever you need to. Alright, so now we're done with this. Now what does it say? Find R when S and K are given. So this is just plug and what? Plug and chug. So I'm going to go over here. So here is, you read, that's 1. 2, you write down the formula. 3, you interchange the variables. And 4, you plug and chug. So R is equal to 13 times 6. And 13 times 6 is what, 48? I have no idea. Y'all got to help me, I don't know. 78? Yeah, 78. I was thinking of something else. Thank you. So that's the first type problem I was telling you, where they give you the numbers and you just you just plug it in and find it. Okay? Now that's not the one that's going to get you. The one that's going to get you is the one where they integrate 2 formulas. And I'm going to let you play with those. I'm not going to show you how to do them. I'm going to let you play with them, because the best way to learn something like that is for you to actually hit your head up against the wall a couple of times. Okay? That's the best way. So I'm going to let you do those. They're real simple once you see it, but you got to read it a couple of times to see it. Kind of like those 3D pictures you stare at, and you don't see nothing until after you stare at it enough and it starts to come out at you. That's the way those problems are. Let's do another. Let's go down to, I hate when they do this. Just show all of them. Okay. Which one did we just do? 14? Where's 14? I don't even see 14. Oh, 23. We just did 23. We just did that one. Let's see what this one looks like. No, that's a mixture problem. That's the one I want you to work on. Very frustrating when it does that. All right, we did 23. Let me do 30. Let me do 37. Okay, try this one. I want to let y'all try it. This is like type 1 or type. This is a third type. This is the third type. No, blame it. Okay, I'm going to have to show you how to do it, because I'm not going to give you enough problems. This is the where you incorporate 2 with 1. Okay. Now the only thing I want to tell you is right here. I want you to highlight this word. Now, when you see the square of D, what do you think of? Most of you will think of the square root of D, and that's not right. Okay. And I've written them emails about this, and they've gaffed me off, so I just quit writing them. That means, this right here means D squared. So do not think of it as this. Okay, think of it as D squared. So you need to highlight that and put D squared. All right, that's the first thing you need to do, and you need to remember it, because this is going to be on the test. D squared is on the test, because most of your questions are going to have something integrating that D squared. Now, what does this say? Okay, so y is equal to, what did you tell me it was, kxz? I think that's right. All right, so I'm just going to cross that out for right now. I'm not going to cross out the whole thing yet, because I'm not ready to. And inversely, as the square of D. Now, what is inversely? Inversely is y is equal to k over what? K over x, right? So that means I'm going to have another variable where? Under here, and I'm just going to call it W. All right? See, they're integrating two. They're doing jointly, and they're doing what? Inversely. So you need to make a note of that. When you see it, just don't put another X down there, because then you're going to think to cancel it out, and then you're going to be totally messed up. All right? So make sure you put a different variable down there. Now we're going to replace our variables. All right? We start from left to what? Left to right. So F. Where does F go? Right there. Thank you, class. All right? Jointly as what? Q sub 1 and Q sub what? 2. And inversely as what? The square of D. Now we've just done the first part of the question. All right, now you do the second part, because there's nothing new about the second and the third part. There's a second part, and then there's a third part. So don't try to combine them. There's a second part and the third part. Where's the second part? I'm going to highlight the second part in green. Here's the second part. And the third part, I'll do an aqua. This is your third type problem. This is your third type problem. 1, you need to change the variables. 2, you need to plug and chug and find what they're asking for. Then the third one, they're going to give you more information to plug into the formula. F is equal to K times parenthesis over parenthesis. What is, I'm sorry, I messed up. There's supposed to be parenthesis here. Most of the time, they're going to be looking for what in the second step? What's the only variable left? K. I heard that. K. So 20 goes here. 10 goes here. 10 goes here. And 5 goes there. All right, finish it. What are you going to do with that K when you find it? Because K is not the answer. K is the what? The constant. What do you do with the constant after you found it? Plug it back into the what? The formula. Yes, you plug it back into the formula or the equation. Because it is the multiplier. It is what makes the formula what? Work. Thank you, class, for the interaction. Now, you do not need a calculator for this. If you use a calculator for this, I'll probably get on to you. 20 is equal to K times, 10 times 10. You might need a calculator for that. Over what? Oh my gosh. 100 divided by 25. 4. And what is K? K is equal to 5. And you take that K and you plug it back where? You plug it back into the original equation. Not the original, but the second original. The one where you transferred the, yeah. So, part 1 is to change the what? Change the variables. That's part 1. That's right here. Part 2 is to plug and what? Plug and chug. And then part 3, they give you more what? More info. So I'm going to take this guy, and instead of, let me just see if I can do this. Let's see if it'll work. Y'all are impressed, aren't you? I know you are. There we go. I know y'all are impressed, even though the colors don't match up. But anyway, there we go. We'll put it right about there. Now I'm going to take part 3, and I'm going to rewrite the formula or the equation with the K in there. F is equal to 20 times Q sub 5 sorry, while I turn that off. 5 times Q sub 1 times Q sub 2 over D squared. Which is going to be 5 parenthesis over parenthesis squared. And what do you think they're going to give us? Q is what? 3, 6, and what? 3. Now you really don't need to even calculate. Why? Because this is actually, show you a trick I learned in the war. 5 times 3 times 2 times 3 divided by 3 times 3. And what happens to the 3's? You left a 10. So the answer to the third part is 10. So that's, now they're going to ask you a bunch of questions. I think they asked 2 or 3 questions. The variation, I think, is going to ask you for this. Okay? They may ask for this. I don't know. Just trial and error. See what, punch one in and see what it says. And then they're going to ask you probably, they may ask you for this one after you find K. They may not. And then they might ask you for this final answer right here. Okay? Question, right, complaint. All right, let's do another. All right, try that one. As soon as I get all the crap off there. Profit P from selling lawnmowers is directly proportional to N. Okay? That should be pretty simple. You don't even have to integrate on this one. Y is equal to K times X. Now, change the variables. And then, plug and chug and see what they're asking for. I don't know what they're asking for because I've never seen this problem before, so this is a new problem. Okay, now what? Well, I'm going to write direct because it says right here, y is equal to k times x. Y turns into what? P is equal to k times what? N. And N is the number of lawnmowers. P is the profit. So we just did that right here. If the profit from selling 10 lawnmowers so part 1. Part 2 is to plug and chug. So divide by 10, divide by 10, K is equal to what? 75. So what do we do in part 3? We rewrite the formula with K is equal to what? And now we do part 3. So P is equal to 75 times what? And that's not hard to do because 75 times 10 is 750. And 2 times 75 is 150. So that'd be what? 200? Right? Something like that. So it'd be what? 800 or 900? Which one is it? Okay. I lost my first digit while I was thinking. Sorry. 900? Like I said, it's once you do 6.1 and 6.5, these should be what? Easy. That's why I teach 6.1 and 6.5 first. So that way it's kind of like, you know, I don't know what it's like. It's get the hard stuff over first. And this seems very easy compared to the 6.1, 6.5. Capiche? All right, y'all get out of here. We'll finish up the unit Wednesday. Okay? So that means what? Coming up? Means another test is coming up. Now, no, wait a minute. Yeah, I break this up into 2 units also. 2 tests. I break it up into 6.1 through 6.5, and then I do 6.6 by itself.